Our goal in this section is going to be to find methods for calculating the volumes of various solids. And so suppose we want to find the volume of a solid like this one, and we want to do this from A to B. So what we'll do is we'll start by slicing the figure with a plane perpendicular to its axis. And this is going to give us a region inside the figure whose area we'll call A of x. Now, if A is a continuous function of x, then the volume of the original shape is just going to be the integral of that area function. Right? And this approach to finding volumes is what we call the method of slices. So to see how this works, think about dividing the interval from A to B into n pieces, whose lengths are b minus a over n, just as we have in the past, right? We'll call this delta x. Right? Then we're going to pick an arbitrary point x sub I in the ith interval. Doesn't have to be. It can't be the endpoints. Doesn't have to be. It can be any point on the interval. Then the volume of this slice is going to be delta x times a of x sub I, where a is that area function I referred to on the previous slide. Now, from here, we can approximate the area of the entire solid, excuse me, not equal, where it's the approximate area, by adding up all of those individual volumes. Right now, finally, we get to the total volume, and just like we did with area, I'm going to take the limit as n goes to infinity of this sum. I'm going to define this to be the volume. And the way we write this, again, just as we've done in the past with these kinds of limits of sums, I'm going to write this as the integral from a to b of a of x dx. Right? That's the method of slices. Right? That's how we're going to define the volume of a solid.